Hey guys, welcome back to Explore Electronics Plus. In this video, let's understand APB protocol, that is Advanced Peripheral Bus Protocol. This is basically a bus protocol which is connected in between the peripheral devices. The first thing is that we need to understand the APB states. We have a state diagram which says the different states of which APB is going to work, and we need to understand the APB signals. And then let us understand write and read transactions through APB, and then let us do a verification project which is having APB wrapper for a memory using UVM or system verilog. And the first thing is that we need to understand where actually this APB is going to be used, how actually the usage of this APB will be. You can see in this diagram, this is a simple SOC which will be having a processor, RAM, DMA bus master, and then external memory interface, and also UART, keypad, timer, and PIO. You can see clearly there is a bridge over here. I will tell you what is the bridge is. Before the bridge, we have all the high performance peripherals which is connected with AHB or ASB. And right side the bridge we have APB bus which is connected to UART, timer, keypad, and PIO. What this indicates, whenever the high performance peripheral is there in our SOC, we are going to connect with AHB or AXI, such kind of protocols which are giving high performance. When there is a low performance peripheral or low bandwidth peripheral is there, we need to use a simple protocol, that is APB. So it says APB is used to interface any peripheral which are low bandwidth and no much high performance is required. Like UART, keypad, PIO, and timer can be connected using APB. And high performance peripherals like processor, memory control unit, or DMA master, and high bandwidth external interface or some RAM will be connected with AHB or AXI. And you may get a question, why actually the bridge is required here. This bridge acts as a translator. Suppose let us take a scenario where English guy don't know Hindi and Hindi guy don't know English. So we need to make a communication between these two guys, means we require a translator in between who know both the signals or both the languages. The same kind of functionality this bridge is going to do. This bridge will try to make the AHB comfortable with APB signals and APB bus comfortable with AHB signals. Then only the communication in between AHB and APB or any other two protocols happens when there is a bridge. We call it as AHB to APB bridge or APB to AHB bridge. So this is the simple block diagram indicating where AHB as well as APB can be used. So the idea is that APB will be used whenever we are going to connect the peripherals which they are going to act with low performance or with less bandwidth. So let us try to understand the signals corresponds to APB now. Since it is a bus protocol, the communication happen through the bus is write-read transactions, and we require a write-read control signals as well as the clock and reset. Here also we will be having P clock, you can see here. Here P indicating a peripheral a bus, that is with respect to APB, and CLK indicating a clock. This P clock will be always connected to, maybe connected to system clock itself. And we have a reset signal P reset N. Here N indicating it is active low signal, and it is a asynchronous reset. Asynchronous reset in the sense it is not synchronized with the clock signal. It will not wait for the clock edge to happen, clock event to happen. Whenever the reset is going to low, it will reset the things. And then with respect to address is concerned, P address is there, PADDR. This is an address signal. This address bus from master to slave. Master is going to give the address. So it is up to 32-bit wide. We can use up to 32-bit address. And we have two data signals. One is PW data, another one is PR data. PW data corresponds to write data. PR data corresponds to read data. Write data indicating master is writing to slave. So through PW data, we are going to send the data values. PR data indicating while the master is reading the transaction from the slave, the data will come from PR data. So these signals are 32-bit wide. We can use up to 32-bit. We can use as 8-bit or 16-bit or 32-bit wide. Then we have P select signal. This P select signal will be used to select the slave. As we seen in the previous diagram, we have multiple slaves connected with APB. We have UART, we have keypad, we have timer, and we have PIO. So in these cases, there are 4 slaves here. We require separate indication to identify which slave it is. So let us take UART is slave 1, timer is slave 2, keypad is slave 3, like that. So if we have n number of slaves, we need to identify them with P select 1, P select 2, P select 3, and so on. That's why whenever the master is connected with respect to slave, the first thing is that slave should be selected by the master. So in APB protocol, remember this, the very first basic thing is that the master should select the slave through P select. Otherwise it will be in idle state. Let us see that in the state diagram later. Let us move on to the next signals. We have P enable signal. As I said, the first thing is P select should be 1, and once it is P select is 1, then we move on to P enable. Master will enable the transaction. So this indicates the second and subsequent cycle of the transfer. Means the first cycle is that P select. When it is 1, then P enable. It should be 1, then we say it is in access phase. After that, we have a P write signal. P write signal indicate whether the transaction is write transaction or the read transaction. And then we have P ready signal and P slave error signal. These two signals are slave signals. All these are master signals. Master is going to give this value or information. P ready and P slave error are slave signals. P ready is 1. It is indicating slave is ready for the transaction. If P ready is equal to 0, the transaction will not occur. It means the slave will indicate a wait state, or slave will put a wait state in the transaction. That is what P ready is. Remember, P ready is a slave signal. And P slave error, it is also a kind of response from the slave for the transaction. When this signal is high, it indicates there is a error in the transaction. The transaction may not complete properly. When slave error is 0, it is indicating the transaction is successful. This is the only response signal we have in APB, where indicating the error or there is no error in the transaction. So let us try to understand APB further with a state diagram. This state diagram indicating 3 stages in APB transaction. The very first thing is idle state. In idle state, as I said, P select will be 0. Until master select the slave, the bus will be in the idle phase. There is no transfer occurs. Once the slave is selected, it will move on to setup phase. In the setup phase, you can see P select is 1. It means the slave is selected and master is not yet enable the transaction. So P enable is 0. This is setup phase. And then access phase, when P enable is also 1. So you can see here in the access phase, P enable is 1. So these are the 3 stages of APB transaction: idle phase, setup phase, and access phase. So you can see here P select 0 idle phase, other signals can be ignored here. But when P select becomes 1, at that time master should give P address, P write, PW data on the bus. It should be ready and it should be valid. But P enable is still 0. When P select is 1 and P enable is also 1, then it will enter into the access phase. At that time, P address, P write, P data, PW data must be valid, and then the transaction may happen. That is the access phase. These are the 3 phases in the APB, and P ready and all, let us see with respect to the transaction is concerned. Let us move on to the write transaction. So now let us go with the write transfer with no wait state first. Later let us see what is wait state and how actually that will be. So any transaction in a APB protocol, it takes minimum 2 cycles. It requires 2 cycles to complete, 2 clock cycles to complete one transaction. So here in the waveform you can see there is a P clock signal and there is P address, P write signal, P select, P enable, PW data and P ready. So the first thing is that in between T0 to T1 you can see P select is 0. The very basic thing is that we need to enable P select. Then only we need to look for P enable. When P select is equal to 0, no need to look for other signals. There is no transfer occurs here. This is idle phase. P select is 0. And T1 to T2 if you see, P select going high. It means master is selecting the slave, it is selected the slave, so it is a setup phase. In this state, P enable should be 0. And meanwhile, P write should be at the valid state, so it is 1. P address should be some address to where the data is going to be written, and also PW data should be ready. You can see here T1 to T2, P select is 1 and P enable is 0. We call this state as setup state. Okay. And T2 to T3, if you see, P enable becomes 1. And data is same, address is same, P write signal also valid. There is no change in the address, there is no change in the write, there is no change in the select, there is no change in the data. In the access phase, you can see P enable becomes 1. If this time, if P ready is 1, at T3, all the data and address is going to be captured by the slave. It indicating slave is ready to capture all these things. So T3 will be the time in which slave is going to read all the data given by the master. So 2 cycles here is that in T1 it is idle phase, we are not going to consider that. T2 will be the setup state where all the signals are going to be sampled here. T3 will be the access state where slave is going to get the transaction, that means the write transaction. So this is how we can understand the write transfer with no wait state. No wait state because P ready is 1 here itself as soon as P enable become 1. So let us move on to the next write transfer with wait state. Here what happens, the only difference is that you can see P select is 1 over here. This is setup phase. When P select is 1 and in the next cycle P enable is also going 1, it means this is the access phase. And the master is expecting P ready to be 1, but P ready is not 1 over here. It is trying to capture at T3, but here P ready is 0. It is trying to capture at T4, here also it is 0. It is inserting 2 wait cycles here. When P ready is 0, the data should be stable, it should wait. P enable should be 1, the master should wait. P select is also 1, P address is also 1, and P write is also 1. The master should wait to complete its transaction until P ready becomes 1. P ready going high over here. It means the transaction will happen at this stage. At T5, all the data will be captured in the slave. So the wait state is nothing but P ready is low, means the slave is inserting the wait states. And all the other things are same with respect to the no wait state is considered. But the condition is that the following signals remain unchanged while P ready remains low. Which are all those signals? P address should be same, P write should be same, P select should be same, P enable should not be varied, PW data should not be varied. And also there are other signals which I am not discussed in this lecture, that is strobe signal, prod signal, PA user request attribute, as well as write data attribute. These are not so important in the earlier stage. We can discuss these in the next stages. But in this video I am not covering these. But the thing is that we need to keep all these signals including address and data while the slave is inserting a wait state. And P ready can take any value when P enable is low. You can see here P enable is going low after the completion of the transaction. It says P ready can take any value when P enable becomes low. When the transaction gets completed, it can take any value, no matter what it is. Then let us understand the read transfer with no wait state. What happens in the read transfer? We are expecting P write should be 0. So P select become 1. At the time we need to set the write signal. So the write signal is 0, indicating it is a read transaction. So we need to set the address. Master is set to set the address. You can see here it is a read transaction. The read data will come only when P ready becomes 1. Why? Because the read data, in the sense we are reading from the slave. When the slave is ready, then only it will give the data, right? That's why in the access phase, when enable becomes 1, here there is no wait state, P ready 1, as soon as P ready 1, the data is available on the bus. But the master is going to capture that at T3. That is what the meaning over here. And let us see with wait states are included. Same explanation again. P select is 1, P enable is 0. There is no data here, but address and write control signal is controlled by the master and it is stable over here. And when it is moved on to the access phase, P enable becomes 1. But here P ready is 0. When P ready is 0, it means the data is not available at the slave. That's why it is postponing. Here also in the next cycle, if you see P ready is 0, means slave is not ready. These two are called as the wait states in this read transfer. At that time, the data is not at all available to the master. The P ready signal goes high at T4 to T5, then the data will be ready. At T5, the positive edge of the clock cycle over here, the data will be read by the master. And you can see over here, P ready is high till T2. It means the slave is ready at this time, but master is still in the setup phase. It is not going through the access phase. That's why there is no transaction happen over here. That is what in the previous explanation I said, when P enable is low, P ready can take any value. P ready can be 1 like this. You can see over here, P ready is 1 when P enable is 0. In this case, even if P ready is 1, we can't get the data, right? This is about read transfer with wait states. And the next thing is we need to understand what is the error response. Error response is that with P slave error. This is the another signal given by the slave in APB. When P slave error is 1, it is indicating error. When P slave error is 0, it is indicating no error. This is with respect to the write transfer is concerned. This is with respect to the read transfer is concerned. It means P slave error can be triggered by the slave in the write transaction as well as in the read transaction, no matter which type of transaction it is. We can expect P slave error 1 given by the slave. P slave error can be used to indicate error condition in APB both in read and write transactions. P slave error is only considered valid during last cycle of APB transfer. Last cycle of APB transfer is what actually? When P ready is equal to 1, then it is the last cycle of the transfer, right? That's why P slave error will be considered only if it is a last cycle of the transfer. And when at that state, when P select is 1, P enable is also 1, P ready is all high. That is what the last transaction we can say. And transactions that receive the error might or might not have changed the state of the peripheral. It means because of the P slave error is 1, the peripheral state is not going to be changed. It means this is not saying the data which is coming as wrong. It is not ensure that the data is corrupted. It will not ensure that master should not take the data. It is not ensuring that slave is not taking the data. But still we have a P slave error. It is indicating that the transaction is not so completed, or it is not a complete correct transaction. It is an error. You can see here this is peripheral specific, and either state is acceptable or not acceptable depending on the particular peripheral which we are using. If it is highly sensitive peripheral we are using with respect to APB, then we may consider this slave error as high priority one, severe case, or we can neglect this also. That is depending on the peripheral which we are going to use. So this is about the transactions and the error response of the APB protocol. Here we need to remember the 3 states: idle state, setup phase, as well as the access state. The very first thing is that P select should be 1, and the second thing is that P enable should be 1, and the third thing is that P ready should be 1. Then only all the transaction will be completed successfully. Let us try to write the test bench and verify APB protocol in the next video. Thank you.